Everyone, welcome to my channel. In this video, we'll be discussing how to interface BH1750 light sensor with SIWG917 and display the alert messages on memory LCD like if the light is too bright or too low or it is normal. So without any further delay, let's open Simplicity Studio and get started. So once you open the Simplicity Studio, you have to go to File, New, Silicon Labs Project Wizard. So you will be prompted with this kind of window where in which you will be selecting your target boards, target device, SDK and IDE. Target boards will be 4002 baseboard, 4338 radio board, and target device will be SIWG917 M111 MGTBA, which is the manufacturer part number of the SIWG917 chip, which is on the radio board. And SDK, you will select the SDK which has Voice Connect in it, and IDE or toolchain, better to go with Simplicity IDE and or GNU ARM. So before clicking on next, we'll quickly delve into the datasheet of BH1750 to know a few major details. So if you can see here, the light sensor is using I2C bus interface. That is, we have to interface with the light sensor using I2C. And let us look for something like instruction set architecture, which will tell us which instruction to be sent to get our data. So here we have instruction set architecture. So for power down, power on, reset, there are different instructions. So we are mostly concerned about getting the data. So we can either go with high resolution mode or continuous high resolution mode 2 or low resolution mode. For now, I'm fixing to go with low resolution mode. So the instruction that I need to send will be 0x, this is 1 and this is 3. So remember the instruction, it is 0x13. Okay, instruction is done. We need to also know the address, right? Because I2C will first we have to address the device that is a slave, and then we will be sending the data or command. So let us scroll further down. So this is related to the processing of information from the BH1750. So in this, he will be explaining how to convert the ADC values into the lux information. So lux is the units of light intensity. So here he will be mentioning how to convert it. If you are interested, you can go through it. I'll keep this link in the description. And moving further down to find the address. Yeah, here you can see slave address. If the address pin is pulled high, the slave address is something called 0x5c, or else it is 0x23. You can see 4 bits, and these are other 4 bits, 0x23. So we are concerned only with address pin pulled low, because internally it is pulled low. If you wish to change the address only, you will pull the address pin high. So let us remember this address pin as address as 0x23 and command as 0x13. Go back to Simplicity Studio and click on next. As it is mentioned that it is using I2C, you have to go through the schematic of BRD4002 to find any device that is using I2C. I leave the link for the schematics in the description. So I have gone through it. So the device which is using the I2C protocol is SI70XX, which is actually SI7021, which is the onboard temperature and humidity sensor by Silicon Labs. You can select it and click on next. So I'll make the project name to be BH1750 alert system underscore MEMLCD, because we will be displaying alerts on memory LCD only. Onboard memory LCD. You have to keep it as link SDK and copy project sources and click on finish. It will create the project and open the README document for you. So this is the README document. You can read it to know which I2C it is using, what are the pins to connect the I2C, and you can see expansion header 16 and expansion header 15 are the pins that you will be using in order to interface or connect the SCL and SDA lines of the device. And yeah, this is about README document. And for now you can close the .slcp file also. Now in this you have to go to the main.c. Always the process starts from main.c. In main.c we have to look for which application is running inside while one. So system is initialized, some data validation, and here we have while one. While one is the only place which will have the code that is running in our embedded system. In any embedded system, inside the while one only code will be running. So you can see SL system process action is being running. Okay, it will have something internal process actions, platform process actions. So this we are not concerned of. What is this app process action? So it is, if you hover it over there, it is saying that it has something called as SI70XX example process action. Let us see. Let us click on it. It is taking to here. So let us see what is inside is. Control click, it will direct you to the SI70XX example.c. So SI70XX process action. So inside the process action, uh, you have something like, you have debug out messages, and here you have the status message. SI70XX measure RH and temperature. For in that function, it is sending I square C, which is the, if you hover it over the function call, it will tell you the function details. So it is sending the I square C instance and the address of the I square C slave and the pointer to humidity and temperature data, so that whatever the humidity and temperature data it is receiving inside this particular function, it will manipulate there then and there itself, but still it will get reflected in the main function. So I square C instance we are not concerned, because same I square C instance we'll be using, but we are concerned of using this SI7021 ADDR. So control click on this, and it will direct you to a place where it is macro defined as 0x40. Now we want to make this as 0x23 as shown in the previous data sheet. So I'll try to edit it. It will show me a warning that I'm editing in the SDK. I'll ask it to make a copy for me. It will make a copy for me. So yeah, it made a copy. I'll go back to the hash defines and change it to 0x23 and save my file and go back to the example.c, the same function, and address is changed. What next? Next we have to change the commands. In order to know which commands it is sending, let us move into this function sl si91x si70xx measure RH and temperature. So it is around in the 291th line. So here, if you read through the lines, you can directly skip this if and else if kind of things, because these are just data validations which we are not concerned of. Here you can see, send humidity hold master mode command and get response from the sensor. Send temperature hold master mode command and get response from the sensor. So these are the two lines, line number 306 and 313, responsible for sending commands and getting data. Here you can see, if you hover over this, the function parameters are I square C instance, address, data, and then what else, and command. So the last one is command. Last one what we have here, sl underscore humidity underscore hm. Let us control click on it. It is directing me to some same file that wherein which we have changed the address. So what command I have to send? I'll send 0x13 for continuous low resolution mode. And similarly I'll change temperature underscore hm also, which is just below the same function. I'll save it. You can see sorry, yeah, you can see here we have humidity underscore hm, here we have temperature underscore hm. Both of them I have changed it to 0x13, which is 19 in decimal equivalent. Now what else? Here it is written that convert relative humidity measurement to percentage relative humidity. So this is something called data processing on the received data. So we are not intended, or we are not wanting this data processing. So I'll just comment out. Again it will ask me whether I am willing to make a copy or edit in SDK. I'll make a copy and remember the line number 311, and yeah, you have to directly navigate to line number 311. Yeah, so you can comment out the humidity data, and similarly you can comment out the temperature data. We are commenting out this only because this data processing is related to SI7021 RHT sensor, but we are not interfacing RHT sensor, we are interfacing ambient light sensor. So this data processing and all will give us a wrong values of ambient light sensor, so we don't want data processing for now. Once you have done everything, you just save it. And yeah, this is all about interfacing BH1750. Now next comes adding or displaying these values into the memory LCD. For that, what you have to do, you have to sit and write code for memory LCD. Is it? No. You can directly open the example file of memory LCD, which you can do from file, new Silicon Labs project wizard, and Again, same thing, target boards, target device. As mentioned earlier, you can select these and click on next. You can directly find for a example memory LCD bare metal. Click on next. You can change the name to some threshold monitoring underscore helper, or yeah, something like that, underscore helper, and click on finish. So it will open the readme file, so you can read through the document if you are interested to, or you can just simply close it. Now let us close everything and let us think for a while. For example, if you are writing programs in C and want to copy a program in a particular project into the another program, what you will do? You'll copy all the libraries and you'll copy the code. Similarly, if you open memorylcd.c app.c, you have these many headers. You don't know from where these headers are coming, but you need them inside your main project, which is BH1750 alert system memory LCD. So what you have to do is you have to simply open the SLCP file in both the projects, that is in memory LCD as well as in your main project. So I have opened the SLCP files. Now what you will do is you will simply copy the software components that are present in memory LCD into the software components of BH1750 alert system. So how do you copy? You can click on the filters and enable install, right click, expand all. Similarly you do for memory LCD. You can go to memory LCD, install, right click, expand all, expand all. So you have to keep on comparing if everything that is present in the memory LCD project have been installed in this. How do you know if it is installed or not? You have applied filters, installed, okay. Another method is if the component has a tick on its left side, it means it is installed. So let us quickly analyze which are there, which are not there, and copy the software components. So yeah, I have copied every software component from the MEMLCD into this our alert system. So once you have copied software components, it is like copying all the headers. Once you have copied all the header folders, the next part is copying the function. So how do you copy the function? You have to go to the example.c in your main project, which is BH1750 alert system, and open uh, you have to open memory lcd.c in the memory lcd program. So you can see it is a single function which is void memory lcd app underscore init, which is memory lcd underscore app.c. So you can simply copy this whole function and go to your example.c, just paste it before any function starts. So here the function is starting, default clock configuration, so you can paste it before this function. Yeah, I have pasted. You can see there are so many errors. This is because the libraries are missing. Libraries are missing in the sense they are installed, but they are not included here. To know which libraries to be included, just copy paste the hash include section of the memory lcd into this example.c, and after that you can copy paste the define section in the define part. So yeah, you can copy paste the define section, and then you can copy paste the static variable section. Yeah, here you can copy paste the static variables. You can see once you have copy pasted everything, all the errors have been gone, so you can just simply save it. So next comes our main part, which is processing. That is processing the incoming ambient light sensor value and deciding it whether it is too low or too high or normal, and based on that displaying on memory LCD. So before moving further, let us define few thresholds. Mm, let us define threshold here. Yeah, hash define. Let us give it name as th underscore low. Lower threshold, let us keep it to be 100, or let's say, yeah, let us keep it as 100. And I'll also keep the upper threshold th underscore high. Let us keep it as 1024. So these are the two thresholds I have defined, And now let me declare two flags, which I will be polling in the memory LCD function in order to know if the threshold is high or low or normal. So I'll maintain two flags, int flag low, let me initially disable it, and int flag high, initially disable it. So once you are disabling it, you will be enabling it only in the SI70XX measure underscore RH underscore temperature function only. So you once you have maintained the flags, now it is time to have the character arrays. So let us have two character arrays. Let us have three character arrays. So one is for displaying the lower data, and one is for displaying higher data. Here data, by data I mean string. Like if something is low or something is high, we have to have a string, right, to say that it is low or it is high. And we can also maintain another character array to say it is normal. So now we have to initialize all these character arrays. So we have initialized these arrays. Now you might get a doubt, why did I start off with declaring flags? Because the memory LCD prototype is having void in it. So instead of parsing parameters into the memory LCD function, I'll just monitor these flags inside the memory LCD function, and based on the flag value I'll display the data. So you can, these both are same things. It is printing, one is printing memory LCD sample app, another is printing hello there. So you can just delete one of them and start your polling. If flag low, let me start with flag high. So what I have to do, I'll start with the routine, which is nothing but I'll disable the flag high is assigned with 0, and then I'll copy this entire function, and in the place of hello there I'll print the string shigh, and I'll not increment the line. Yeah, this is for if flag is high. Just copy paste it and replace this if with else if. uh, Instead of high we have low. Here also replace the flag of high with low. Here also instead of high you replace it with low. So we are done with flag high and flag low. So yeah, now next thing is dealing with the normal values. Keep it else. Just simply uh, copy this whole function and paste it here. Instead of hello there, you have to print something called norm. Is it right? Let me check it. No, it is s of 7, so I have to print s here. So yeah, I'm printing s, and then you can remove this because we have already dealt with this. This is no longer required. So yeah, we have taken care of everything, and we have monitored the flags, we have disabled the flags if they are there, and the next pending part is enabling the flags. Where do you enable the flags? Inside the function which is their example process action. So here you are receiving the humidity and temperature values, and before printing it in the debug out, you can just update the flags, like if humidity, or you can just yeah, you can, no need of sending two times, you can just remove the temperature debug out message, and instead of sensor humidity you can say ambient light sensor value is. So you can say like if humidity is greater than th underscore high, so you enable the flag called flag high is equals to 1. If humidity is less than th underscore low, so flag low is equals to 1. Yeah, so these are something like these are the only ways you will enable the flag based on the humidity values. So once you are done with this, you can just call the memory LCD function, memory LCD underscore app underscore init. So yeah, let me check if I have spelled the function name correctly. Memory LCD underscore app underscore init. Uh, Let me copy the function name to avoid errors and paste it here. So I'll just paste it, so it is the same thing. Yeah, this is what you have to do. uh, Let me give you a quick recap. You'll first change the address and then change the command, and then load the software components from memory LCD into the SI70XX example, and then you will copy the headers and the function from memory LCD underscore app.c into SI70XX underscore example.c. After you have copied everything, you will maintain two flags and two thresholds, and based on the thresholds you will be enabling flags and calling the memory LCD app underscore init function, and you will be monitoring for the thresholds inside the memory LCD function. Based on the thresholds you will be printing different strings which will be declared globally. So you can just save this, and for now I don't have the board, so I'll just build it to know if I have any errors in my code. So right click on it, you can build project. Let us see if we have any errors. So you can see there are no errors and warnings. So whatever the code we have written is correct. So whenever you are trying to integrate two things, like if you want to integrate memory LCD with any of the examples, this is the only method. The first thing is you will copy the software components into your target location. In my case the target project was SI70XX. In your case it might be different, like if you are interfacing pinging of Google and want to display the ping data on memory LCD, your target application will be Wi-Fi SoC ping. So there you will be navigating to SLCP and then copying the software components, and then again the same thing, you will be opening the example.c, copy pasting the headers, copy pasting the memlcd app underscore init, and again what you will do is, he instead of maintaining flags, you can just say parse a string into the global variable, like you can declare the global string variable and do it global string variable and display the string inside the memory LCD function. So this is the way you integrate BH1750 with memory LCD and display the threshold values. So if you like the video and find it informative, please do like and share it with your friends. If you have any doubts regarding the video, please do comment them, and don't forget to subscribe to my channel Tech Talks. Thank you.